All right, so quickly again, scatter plots, good first step in evaluating reliability. More common, more efficient way is to use the correlation coefficient R. R is a single number that describes how close the dots on a scatter plot are to the line drawn through them. We look at the slope. That lets us know whether it is positive or negative. A and B both have positive slope. C has negative, D has none. Then we look at the strength. Positive and negative range from negative 1.0 to positive 1.0. Negative 1.0 and positive 1.0 are equal strengths. The negative or positive, again, just tells you the slope of the line. 0 means there is zero relationship, so D, right up here, would be R equals 0. In test, retest reliability, you'd measure the same participants at least twice, time 1 and time 2, and then compute R. You would input your time 1 scores and your time 2 scores, and then compute R by a computer. If R is strong and positive, 0.05 or above, then you have good test, retest reliability. If R is positive but weak, it is a sign of low test, retest reliability. Note that test, retest reliability is only relevant for variables that do not change over time. It would not be relevant for something like weight. It probably would be relevant for something like an adult's height. Inter-rater reliability. 2 observers rate the same participants at the same time, and then an R relationship is computed. If R is positive and strong, 0.70 or higher, you have good inter-rater reliability. If R is positive but weak, you do not have good inter-rater reliability. A negative R would mean terrible inter-rater reliability. Think about that for a second and maybe try to come up with why on your own. When observers are rating a quantitative variable, R is the appropriate statistic. However, when a variable is categorical, the appropriate statistic is a kappa, K-A-P-P-A. You do not need to worry about that. The reason negative R would be terrible inter-rater reliability is because, remember, we get negative when one variable goes up and another goes down. So that means your raters would be rating at complete opposite ends of the spectrum, which we do not want. Internal reliability. This is relevant for measures that use more than one item to tap into the same construct. So if you have 2 surveys you are using to measure happiness, a set of items has internal reliability if its items correlate strongly with one another. In that case, you can average across those items to get a single overall score for each participant. Cronbach's alpha is the statistic used to evaluate internal reliability. We will talk about that one more later. All right, inter-item correlation. This table shows how researchers can test for internal reliability by having people answer different versions of a question and measuring the correlation between how people respond to the different questions. They can then compute the average inter-item correlation, AIC, which is the average of all the correlations between the different items. If the AIC, or Cronbach's alpha, is acceptable, then there is good internal reliability. We'll talk more about Cronbach's alpha later on. So this negative 0.01 is not a number that you want to see when you're looking at. So item 4 maybe is probably not related. 0.01, negative 0.05, 0.02, we look at it. I am fond of polka dots. Is probably not related to, in most ways my life is close to my ideal, the conditions of my life are excellent, I am satisfied with my life, and if I could live my life over, I would change almost nothing. So this is letting you know item 1 and item 5 are related well, 0.32. Item 2 and item 5 are even better related at 0.40. Item 3 and item 5 are related at 0.23. Item 4 is not related to item 5. You guys can do that part on your own. Alrighty. That's where we're going to start on Thursday. Okay.